So, section 4 in chapter 10. Find the probabilities of disjoint and overlapping events. So I started right away with the warm-up, so take just a second to do this warm-up. Okay, so here you go. The first one was the probability of a red card. If you pulled a card from a deck of cards, it's half of them are red, so it's 26 out of 52, which is 1/2, 50% chance. It's kind of obvious. Probability of pulling a 10. Well, there's 4 10s, so 4 out of 52 is reduced to 1 over 13, which is approximately 8%. It kind of makes sense if you think about that too. What's the probability that 2 flipped coins show heads? Well, for the first flip you have a 1 out of 2 chance, and for the second flip you have a 1 out of 2 chance. You multiply those together, you get 1/4 or 25% chance. All right, we're going to look at some different types of events occurring in probability. You could have a compound event, which is the union or intersection of 2 events. So for example, just cross that off, that's not really important there. For example, if you had 45 students and 17 of them were taking chemistry, 22 were taking biology, and there's 9 of them that are taking both chemistry and biology. This would be an overlapping event or a compound event, and we could kind of determine the probability of that occurring based on this information. Events that share the same common outputs, overlapping events, are compound events. And then here, disjoint or mutually exclusive, we're pretty much going to use this word disjoint rather than mutually exclusive, is 2 or more events with no events in common. So for example, using the same kind of instance here, instead of any overlapping, we have students in chemistry and students in biology, and there are no overlapping ones at all. So nobody's taking both classes at the same time. That's a disjoint events there. So let's just start by finding out how to find the probability of some of these. The probability of compound events. So if A and B are any 2 events, then the probability of these things happened are the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. If A and B are disjoint, like this, then the probability of A or B is this occurring. Probability of A or B is equal to the probability of A plus the probability of B. Let's just practice this a little bit. So it says a 6-sided die is rolled. What is the probability that the number rolled is less than 3 or greater than 5? So I got props here. So it says a 6-sided die is rolled. What's the probability that the number rolled is less than 3? Well, the only chance of that happening is with a 1 and a 2. So this would be 1 and a 2. Or greater than 5. The only way that would happen is 6. So it's a disjoint event because there's no overlapping numbers here. There isn't a number that meets both this condition and that condition. So if we follow this equation right here, we can find out the probability of this happening. So the probability of A rolling a number less than 3 is 2 out of 6 possible. And then we have to add it to this, the chance of this occurring, which is only a 6, so there's only a 1 out of 6 chance of getting a 6 if we roll this die. So we have to add them together. Since the denominator is the same already, you just add the numerators. It'd be 3 out of 6, and that actually equals 50%. So you have a 50% chance of, when you roll a die, getting a number less than 3 or a number greater than 5, which kind of makes sense because it's 3 numbers out of 6. Kind of makes sense. All right, so let's look at this one now. We're rolling the same die. What's the probability of rolling a number greater than 4 or even? All right, so greater than 4, the possibilities of greater than 4 are 5 and 6. That's this right here. The possibilities for an even number are 6, 2, and 4. Oh, I shouldn't draw a line under there, sorry. So look, 6 meets both criteria. So this then is an overlapping event. So we're going to use this other formula right here. So it's going to be the probability of A or B occurring, one of these things occurring, is equal to the probability of A, which has 2 possibilities. A 5 and a 6 is 2 chances out of 6 possible numbers on the die, plus 3 numbers that are even out of 6. That's event B, so we could say that's event A and this is event B. But then we also have to minus the probability of A and B occurring, which is this right here, A and B occurring. We have to minus that, which is 1 out of 6. And when we do that, since we have the same denominator, it's 2 plus 3 is 5, take away 1 is 4 over 6. Reduced is 2/3, which is going to be about 67% chance of this occurring. A number greater than 4 or even, which kind of makes sense if you think about the numbers on the die. So basically you're deciding whether the events are disjoint, and then you have to just plug it into the right formula. So on the back side here I kind of listed the formulas or the equations for you again, but I added this in because I want you to think about it. It says if the probability of A and B is equal to 0, that tells you that the events are disjoint, because if you look at this, if I want to find out the probability of the students in this particular, these two events, both taking chemistry and biology, it's 0, because none of them take chemistry and biology. So it has to be 0. So if that's the case, if the probability of A and B is 0, that means they're disjoint. Okay, so let's do what we got to do here. Find the indicated probability and state whether A and B are disjoint events. So giving me the probability of the first event occurring and the second event, and they're giving me the probability of A or B occurring, I need to find A and B. So I'm going to use this overlapping equation right here, because that includes all of those things. So the probability of A or B was 0.5, the probability of A was 0.25, plus the probability of B, which is 0.4, minus the probability of this occurring, which I don't know. So I'm going to just make that X for now. It's easier than writing this whole thing out. Okay? And then it's just kind of an algebra problem that I have to solve. So 0.5 equals 0.65 minus X. If I subtract 0.65 from both sides, I get negative 0.15 equals negative X. And then divide both sides by negative 1, and X would equal 0.15. So I also need to tell whether this is disjoint. Well, no. There's a 15% chance that the probability of A and B are going to occur, meaning there's an overlapping little piece in these two events, because there's a 15% chance of that occurring. So these are not disjoint. Since there's a chance of overlapping. All right, so let's try another one. Here I have A, B, I have A or B, and A and B. Oh, look right here. This is 0, so I can automatically tell that it's disjoint. There's no chance of the two events overlapping. So I need to find A. I'm just going to, again, I'm going to make A my X. It's my unknown. So I'm going to plug it into this equation. Probability of A or B occurring is 0.65. Probability of A is unknown. Probability of B is 0.38 minus 0. So really I'm just solving for X. All I have to do, this kind of goes away, is subtract 0.38. And X equals 0.27. So 0.27 is the probability of A occurring. And since this is 0, the events are disjoint. All right, let's try this again. In a story problem. Oh no, not a story problem. Oh yeah. Of 100 students surveyed, 92 own either a car or a computer. Okay, this is my A or B right here. Also, 65 own cars and 82 own computers. So I'm going to say this is my A and this is my B. What is the probability that a randomly selected student owns both a car and a computer? So I'm looking for A and B. So if you kind of just stop and identify what's all in your story problem there to help you set it up. All right, so I'm working with this equation because I want to know if there's an A and B here. I'm going to plug in what I have. I'm just going to write that down here. Minus the probability of A and B. So I'm going to plug in what I know. I know that 92 out of 100 own either a car or a computer. That's the probability of this occurring. The probability of A out of occurring is 65 out of 100. Probability of B occurring is 82 out of 100 minus, I don't know how many, X out of 100. Okay? So I'm just going to make my life easier. I don't want to work with all these fractions, but since they're all a denominator of 100, basically if you think about multiplying through by 100, we can get rid of the fractions. And we can just use these numbers to solve for X. A lot easier. Combine these two, I get 92 equals 147 minus X. Subtract 147, I get negative 55 equals negative X. And if I divide both sides by negative 1, X equals 55. So I can now say that the probability of students owning both a car and a computer is equal to 55 out of 100, which is a 55% chance that students own a car and computer. All right. The last thing we have to look at for this section is the probability of the complement of an event. So the probability of the complement of A is the probability bar A equals 1 minus the probability of that event occurring. So complementary events are two events that together cover all the possibilities, and an event and its complement always equals 100%. So a card is drawn from a standard deck of 52 cards. Find the probability of each event. So this is kind of like what you were working with in 10.2. The card is not a 7. Well, I know that there's 4 7s in a deck of cards. And I have to use the complement here. So I'm gonna take a 1 and I'm going to subtract the probability of getting a 7. So it's 4 out of 52. Well, in order to do that, I have to have this in the same form as this. So it's actually 52 over 52 minus 4 out of 52 is equal to 48 over 52. And you say, well, yeah, why can't we write that right there? You could, but if it says use the complement, I got to see this work. So 48 out of 52 reduced is 12 out of 13. Now, you may see these problems worked out in decimal form as well. So as a decimal, it would be like this. 1 minus 4 over 52 as a decimal is 0.077. And actually, I rounded this, so when I subtract this, I kind of have to do an approximate 0.923, which is about 92%. Now, that kind of makes sense if you look at this fraction and that percentage. They represent the same thing, the probability that the card is not a 7, which ultimately also makes sense because there's only 4 7s out of 52 cards. So it's a 92% chance you're not going to get a 7. Sometimes you should just stop and say, wait, does my number make sense? All right, one more example. The card is not a red face card. Well, there are 6 red face cards. 2 red jacks, 2 red kings, and 2 red queens. So using the complement, I need to do 1 minus 6 out of 52, the probability of getting a red face card. So 52 over 52 minus 6 out of 52 equals 46 out of 52, which reduces to 23 out of 26, which again is a pretty high probability, which makes sense because you want to know the probability of not getting these 6 cards. So there's a lot of cards that are not red face cards. And that's it.